In this video, we will try to understand how we can perform feature selection using any meta heuristic algorithm. So we can use any meta heuristic to perform feature selection. For feature selection, either you can use traditional techniques, or on the other hand, we have intelligent techniques, that is also known as advanced feature selection techniques. So you can see we have a number of traditional techniques that we can use for the feature selection. For example, we have here filter methods, tree-based methods, or we can use principal component analysis, lasso regression, and many others. So either we can use these traditional methods to perform feature selection, but they have certain limitations. We cannot apply them to a large dataset. So either we can use the traditional method or we can use the advanced method for the feature selection. Using traditional methods, we can choose a subset of relevant features from large set of features in the dataset. And here we use different intelligent algorithms to perform feature selection. Advanced feature selection techniques use different intelligent feature selection techniques to select features. Even they can automatically detect the important features. Using intelligent feature selection techniques, we can manage high dimensional data, or we can optimize the features for the best performance. And if you want even more better results, then you can combine supervised machine learning techniques with the swarm intelligence. So you can see we have a number of intelligent techniques. They are also known as swarm intelligence. Either we can use particle swarm optimization. For example, you can see we have particle swarm optimization, genetic algorithm, and colony optimization. Like that, we have a number of swarm intelligence techniques that we can use for the feature selection. And the advantage of using modern feature selection technique is they can perform better than the traditional methods, and they can also deal with the large data set. And here you can see the advantages if you are using the intelligent techniques. So these algorithms can automatically identify the relevant features. They can handle high dimensional data, and even they can optimize the feature subset for improved model performance. Or we can use deep learning based feature selection. These intelligent algorithms offer powerful capabilities for the feature selection as comparison with the traditional methods. So when we are doing the feature selection, first we will perform pre-processing. This one is important step. Using pre-processing, we can reduce the data set, and after that we will perform the feature selection phase. Here we can select the optimal and the relevant features for the further classification. So initially, feature dataset are decomposed into subcomponents, that is based on the needed feature for the further classification. And after that, the fittest component used for the different grouping, and then the selected components are further optimized using the meta heuristic algorithm. And after that, we can apply the modified KNN classifier for the feature classification. Now we will try to understand how we can perform feature selection, and we will use here particle swarm optimization algorithm to perform feature selection. Here, instead of particle swarm optimization algorithm, you can use any other meta heuristic algorithm. And if you are new, you don't know this algorithm, then we already discussed this algorithm in details using numerical examples, Python code, MATLAB code, and other. You can check this video for more details. So right now we will just follow the particle swarm optimization algorithm main steps, and then we will know how we can perform the feature selection. Here first we will define the objective function. After that, we will initialize the population randomly, and after that we will apply any meta heuristic. After that, we will evaluate each solution, that is feature subset, using the objective function. And after that, we will select the best feature subset that is found after predetermined number of iterations. And then we will validate the selected feature subset, and then we will perform the fine-tuning of the feature subset. This one is optional. So our objective is here to find the optimal feature subset that result in highest performance of the classifier. So particle swarm optimization algorithm, all steps you can see here. First, we will initialize the population. So when you will initialize the population for the particles randomly in the search space, in this population, each particle represents a feature subset. So first we will initialize the population randomly. Here, each particle in the current population represents a feature subset. After that, we will evaluate the performance based on each particle feature subset using classifier by the. Then after that, we will update the personal best and the global best position of each particle based on their performance evaluation using objective function. And then we will update the velocity for each particle, and then we will update the position in the search space, and then we will repeat the steps until the stopping condition is met. And when the stopping criteria is met, we will select the best feature subset and we will represent the best feature subset using global best solution. And then we will evaluate the performance of the classifier using selected features on the testing dataset. And then we'll perform the comparison. Now we will try to understand using a mathematical example that how the feature selection is done. So here we will use simple mathematical example where we have a data set. So first we will define the data set. So we start with the data set that contain features. Suppose we have features x1, x2. We have two features x1, x2, and we want to perform feature selection using basic binary encoding approach. Done. So now we are using here the binary encoding approach. So we will represent the each feature set using binary encoding. In binary encoding we have two digits 1 and 0. 1 indicates that the feature is selected and 0 indicates that the feature is not selected. So for this simplified dataset, we have four possible feature subset. x1, first subset we have x1, second subset we have x2, third subset we have x1, x2, and fourth one, that is no feature selected. Now we will present each of these feature subset using the binary encoding. First subset we have x1. So binary encoding for this we have 1 0. It means here 1 means x1 feature is selected and 0 means x2 feature is not selected. Same for the second subset x2, we have the binary encoding that is 0 1. 0 means that x1 feature is not selected and 1 means x2 feature is selected. And after that we have x1, x2 dataset. The binary encoding for this we have 1 1. It means both x1 and x2 are selected. And then we have none. It means none. When no feature is selected, then we have the binary encoding 0 0. It means neither first nor second feature is selected. We have the binary encoding. Now we can apply any simple feature selection algorithm to find the best feature subset based on some evaluation metrics. Here we can evaluate. Here we can check this based on accuracy or the correlation. So once the best feature subset is identified, we can decode the binary encoding to determine which feature are selected. For example, if the selected binary encoding is 1 1, it means both x1, x2 features are selected for the final subset. And if 0 1, it means only x2 is selected. If it is 1 0, it means only x1 is selected. And if it is 0 0, it means none is selected. Now we will apply the particle swarm optimization for the feature selection. So first we will do the binary encoding of the feature subset. So we have suppose two features x1, x2. We have total 2 raised to power 4 possible feature subset. And each subset is represented by a binary string length of 2, where each possible position in the string correspond to one of the feature. Done, as we already discussed before. So for example, x1, it means x1 represented by 0 1 0, so we have feature subset x1. We will represent this with 1 0, x2 0 1, x1 x2 1 1. No one is selected, 0 0. Apply the PSO. After that we will apply PSO. Then we will apply the particle swarm optimization algorithm here, and in the end, when the stopping condition is met, we can decode the selected feature subset, that is decode the binary encoding of the global best known position, that is the GBEST, to determine which features are selected in the final subset. So like that, we have a number of ways we can perform feature selection using meta-heuristic algorithms. So when you are using the meta-heuristic algorithm for the feature selection, here first we need an objective function that evaluates the quality of a subset of features. First, define your objective function. That function we are using here to evaluate the quality of each of subset of features. Here you can define the objective function based on classifier accuracy or clustering quality or regression errors or other metrics. And we know how meta-heuristic algorithm works. They perform different iterations, and after that they display the best solution. So your objective function should be efficient to evaluate, since it will go through different iterations. So when you have the objective function, you can initialize the population randomly in the search space. Here population, here in the population, each agent we have the feature subset. Then we will apply here the algorithm, whatever algorithm you want to use, PSO algorithm, GWO, or genetic algorithm, or any algorithm you can use here. Then the algorithm will iteratively explore the solution space to find the optimal or near optimal solution in each iteration. And algorithm will also generate the new solution, that is the feature subsets. This one is based on the current solution and their fitness value according to the objective function. So when new solutions are generated, we will evaluate this new solution using the objective function. So here evaluate each candidate solution, that is the feature subset, using objective function to determine this quality. Then we will update the solution. Here we will update the current solution based on the optimization strategy of the meta-heuristic algorithm and select the best solution for the next iteration. And after that, we will check the stopping criteria. If the stopping condition is met, then we will stop, else we will repeat the steps. And when the stopping condition is met, we will select the best feature subset that is found during optimization process based on the objective function values. And after that, we validate the selected feature subset using separate validation. Here for the validation, we can perform either separate validation dataset or cross validation to ensure its performance. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.